All right, so let's review real quick what we talked about yesterday. So let's get all phones and all that stuff away. Uh, we were looking at a little bit more complicated rational functions, right? And our goal here is we just want to be able to sketch these things based on what, and we can do a really quick sketch. Uh, we'll be able to fill in a few more blanks and do a more accurate sketch when we get to calculus. But for now, we just want to know what the general behavior of these functions is going to be. And there's a lot of stuff that we can tell really quickly. So this is not hard stuff at all, but it's really valuable. Okay, so what we looked at yesterday was we wanted to look at the relationships between the zeros of the numerator and the denominator, and where the zeros of the function are and where the vertical asymptotes are, right? So we said that if we have a fraction, we know the behavior of the fraction equals 0 when the numerator is 0, right? And a fraction is undefined when, I want you to get rid of Gibson, get rid of fraction is undefined where the denominator equals 0, right? So where are the places where the numerator is 0 in this case? X equals 4, right? So we know that the function is, and x equals 4 is not a 0 of the denominator, right? That's the other thing I should mention, is that if you end up with a value that produces 0 over 0, well, that's indeterminate, and it really doesn't equal 0 there, right? It's undefined, okay? But in this case, when x equals 4, we end up with 4 divided by some number, 0 divided by some number, and that gives us plain old 0, right? So we know that if we were to make like a t-table, f of 4 equals 0, right? So on our graph, if we're going to sketch a graph, that's one point that we know, right? We know the function goes through that point. Okay, what else do we know? What about the zeros at the bottom? What are those?
Negative 1, 1.
Okay, what's going on at negative 1 and 1? Somebody else? Raise your hand, somebody else. What's going on there? What do you think? Joe, what's going on there? Say it again. So the zeros of the denominator are at, those are important points. They're at negative 1 and 1, but those aren't values of those aren't zeros of the function. What's going on there? It's undefined, so they're asymptotes, right? Okay, and we're going to have to be a little more careful about that here real soon. But for now, we know they're undefined, so we'll associate those with asymptotes. So we know that the function has to, think what the behavior of an asymptote is. As we get far away from the origin, so as we get real high or real low on this function, it's going to start to stick to those vertical asymptotes, right? So how do we know which one it does? Because there's a couple different behaviors that could be happening here. For example, as the function approaches negative 1 from the left, it could be plunging down forever or it could be going up forever, right? We got to know which one it is. And so the way we can do that, and this is kind of a calculus idea, but it's not like it's this irretrievably lofty idea. It's really no big deal. If we take a limit as x approaches negative 1 from the negative direction, from the left, we're just going to see what that gives us, right? So if we take the limit of f of x as x approaches, how do I say 1 from the left? Somebody, right? Remember from yesterday, we're going to say that's going to be, we're approaching, let's do negative 1, sorry. Negative 1, but if we want to say we're approaching from the left, we're approaching from the negative direction, right? This is the positive x-axis to the right and the negative x-axis to the left. So we're approaching from the negative direction. So we're going to put a little superscript there that's a negative. That just tells us the direction we're coming from, right? Okay, what does that give us for each of these factors in this rational function? What's the value of the numerator going to be as we approach negative 1 from the left? Not that it even matters the direction in this case. What value does that approach, Maisie? If I'm approaching negative 1, the top is approaching negative what? If x is approaching negative 5, yeah, right? Because I'm going to end up with a negative 1 minus 4 is negative 5. Okay, on the bottom, what about, I'm going to have two factors on the bottom, right? Let's see, I've got a, what about this one right here? As I'm approaching negative 1 from the left, let's do this guy first, the second one. What's that going to approach, Emily? Negative 2. Okay, so that one's going to become negative 2. Now what about this one? This is the kind of weird one, right? What's going on with that? As x approaches negative 1 from the left, what is going to be the value of x plus 1? What do you think? What's that going to be? Luke? So that's going to be something like negative, give me an example of a decimal that would be like negative 1, approaching negative 1 from the left.
Negative 1.0000001.
Okay, so it'd be negative 1 point something, right? It's a little bit more negative. It's a little bit further to the left than negative 1. Okay, so look, what's that going to be? If I add that to just plain old positive 1, I'm going to have a little bit left over, right? Is it going to be negative or positive? Negative, right. So then we call that something like 0 minus, right? And that's just a, what does that really mean? Well, it's approaching 0. It's vanishingly small, but it never actually gets to 0, right? At 0, this function would be undefined. It's going to have an asymptote, right? So that's not part of the domain. We can't get 0. But we can get as close as we want to. In math, we'd say we can get arbitrarily close to negative 1, right? Which makes which makes this factor as small as you want to be. There's no number that's too small for us to get there. There's no decimal that's too small, but it just never gets all the way to 0. So then what's the behavior going to be? What's the magnitude of this fraction going to be? If I've got negative 5 on the top, on the bottom I've got this incredibly small number times negative 2. What's the size of the bottom going to be as this number approaches 0? Okay, I don't care about the sign yet. What's the magnitude though? I mean, it's still going to get small, isn't it? Right? 0 times negative 2 is still 0, right? You get the idea? So on the bottom, we're still getting this really, really small value, which makes the fraction explode. So we know that the magnitude of this thing is going to be infinite. The question is just, what's the sign going to be, right? And to find out, all we have to do is just look at the sign rule, right? We've got 3 factors there. If we take into account the signs of the 3 factors, we can figure out what the sign of the overall function is going to be, right? So what's that going to be? If I have a negative on top, in fact, all of these 3 are negative, aren't they? So if I have a negative divided by a negative times a negative, that's an odd number of negatives. And so what's the sign of the overall function? Negative. And so it's going to approach negative infinity. That may not seem like a big deal, but that's everything for us. I mean, that tells us the whole macroscopic behavior of this function then is that as we approach from the left, it's going to go down like that. Right? It's going down to negative infinity. Okay? So what about in between? What about in between these functions here? Or in between these asymptotes? We'd have to do the same kind of thing, right? We're just going to take a limit. If I want to know what the behavior is on the right side of the asymptote at x equals negative 1, how am I going to set up that limit? Duncan, what am I going to do? I'm going to say, so I'm trying to figure out what's going on, what the other half of that asymptote is going to do, how the function sticks to it. So I got the limit of my function, right? As x does what? What value are we approaching there?
Negative.
Okay, yeah, but x is approaching what value?
0.
Mm.
Or, I mean,
We wanna know, here's the asymptote. The asymptote's at -1.
Yeah, so be approaching
Okay, from which direction this time?
positive.
From the positive, yeah, we're gonna be walking backwards towards -1 from the right, and we wanna see what the behavior of the function's gonna be as we do that, right? Does that make sense? Okay, and the notation, I realize the notation's a little bit different, but just think about conceptually what we're doing here, right? We just wanna know, as we glom onto this asymptote, which way are we gonna be forced to go, up or down, right? So what's that gonna give us then? The values of the factor x minus 4 and x minus 1 aren't going to change, right? Because the value we're approaching is -1, right? Does that make sense? So as x gets closer to -1, the top is getting closer to the value -5, just like before. The factor x minus 1 is getting closer to the number x, or -2, right? But what's going on here? As x approaches -1 from the positive direction, what's that gonna look like in terms of a decimal? Drew, what do you think? So if I'm approaching -1 from the right side, give me a decimal that would maybe represent a value that's close to -1 as we approach from the right side, from the positive direction.
I'm not really sure.
Okay, Matthew?
-0.0001.
Okay, so that would be, you're right, that's gonna put us about right there, isn't it? I could keep going. What's it, I mean, I'm gonna get -0.5, -0.6. The point is, I can never get to -1. What's another example? Yeah, -0.999, right, so we can get really close to -1, but we can't ever get there. But we're approaching from values, from the positive direction, so we're approaching from values that are larger than -0.1, right? So then what kind of a leftover are we gonna get there? If I have like -0.99999 plus 1, I'm gonna get a slightly positive leftover. And so we'd call that 0 plus, right? So we know that, once again, we got a 0 on the bottom, so we know this is gonna be infinite, but this time I've only got an even number of negative signs that are being multiplied and divided, right? And so I end up with positive infinity, and so what's it doing? Well, in here, it's doing that, right? Okay, make sense? Okay, what about as we approach +1? What's gonna happen there? Let's not even write out the whole limit thing this time. Let's just inspect the function and get our numbers that way. As x approaches +1 from the left, so that's gonna be a number like what? 0.999 kind of a thing, right? We're gonna be a little bit less than 1. On the top, I'm gonna get what? -3, everybody agree? Right, we're approaching a value of 1. 1 minus 4 is -3. So on the bottom, we're gonna get, what's this gonna be? So if I do approaching 1 plus 1 is gonna give me a 2. And what about here? X minus 1. What's that gonna be? Alex, what's that gonna be? Yeah, I noticed that. So if x is approaching 1 from the left, that's going to be a value that's a little bit less than 1, minus 1. What kind of a leftover are we going to get? But positive or negative?
Negative.
Right? I've got something like 0.999 minus 1. It's going to be -0.0, right? See what I'm saying? So it's going to be a 0 negative. What's the overall sign? Positive. Okay, so then that means it's gonna have to loop around and go back up, right? It's gotta stick to the asymptote at +1. When we approach from the left side, it's going up. Yep.
So you're essentially graphing the quadratic formula of the denominator, as if it were quadratic?
No, not really. It's a little more complicated than that. All the bottom is doing is it's giving us the places where the function is undefined, where we have to check the behavior of the asymptote, right? We have to get real close to it and just see what happens, right? As we get really big, we gotta know what the sign of the function is gonna be. Okay, and then the last one, if we're gonna approach +1, x equals +1 from the right side, that's like 1.0001 kind of a thing, right? What's that gonna give us? So we're gonna end up with on top, Jesse, what's that gonna look like? If x is approaching a value of 1, what's the top gonna be? If x is approaching a value of 1, I just wanna know what's the expression x minus 4. What's that gonna become? If x were approaching a value of 9, then we'd end up with, that would look like 9 minus 4 is 5, right? But if we're approaching a value of 1, what are we gonna get? Negative number, negative, and it doesn't matter even what the number is, it's just not, it's -3, but it's a negative number. Okay, what about right here if we're approaching a value of 1? What's that gonna give us? Lexi? But if x is approaching 1, well, you get 1 plus 1, right? Because the factor has the factor is equal to the expression x plus 1. As x approaches 1, that factor approaches 1 plus 1, which is 2, okay? This is the one that's gonna be weird though, right? That's the one that approaches 0, right? So, but what kind of 0? We gotta know what the sign is, right? If we're approaching 1 from the right, that's gonna be a value, an x value that's a little bigger than 1. And so, Maddie, what's that gonna give us?
It's x minus 1 and it's approaching 1.
It's x is approaching 1 from the right this time, right? We're approaching from over here.
It's gonna be like it's gonna be as close to 1 as it possibly can.
Right. So it's gonna get arbitrarily close, but it's always gonna be a little bit bigger, right? So like, what would that be? Like 1 point something minus 1. Infinitely small, but the sign would be positive. Good. So we'd end up with a 0 plus there, right? So we know that if we look at the behavior of this expression then, the 0 on the bottom makes it infinite, right? But I've got 2 positives and only 1 negative. And so it's gonna be a really big number and it's gonna be negative, right? Just like any other quotient of numbers here, a negative divided by a positive times a positive is negative, right? That though makes it infinitely big because like we said yesterday, when the bottom of a fraction gets small, the fraction gets big, right? And so then on this side, it's diving down. And so that's a rough sketch of what the function looks like, right? At least that takes into account all the vertical stuff, right? We've looked at how these vertical asymptotes are manifested in the behavior of that function, right? Okay, let's do one more of those. You guys try one of those. Okay, try that one. Everybody try that. Put that in your notebook. Make a quick sketch of that. And I want to know specifically, I want to know where the zeros of the function are and where the vertical asymptotes are. Okay, Jessica, tell me something interesting about this. Tell me, is there an X value where you know the value of the function is equal to 0? On the, where the function, where would a fraction, which one of these fractions equals 0? The second one? Okay, the second one is, remember, you can't divide by 0, right? So that's one that's illegal for real numbers, right? You can't do that. 0 divided by anything, though, is gonna give us back 0. Okay, so now let me ask you that question again. Is there a place, can you tell me a place where this function is equal to 0? A value of x that's gonna make the top of the fraction 0. Okay. Anybody else want to, Billy? -3. Okay, how come?
It's divided by 5.
Okay, well, okay, because that's a 0, isn't it? If we set the top equal to 0, and just think about this in terms of when we ask something like, like where is the numerator equal to 0? Well, what you can do is you can just say, okay, take the whole numerator, set it equal to 0, that's all, right? At least in your head, you're doing that. You're asking, okay, what are the values that's going to make, what's one of the values that's going to make this product equal to 0, right? It's already factored for us. If it weren't factored, it'd be a little bit harder. Then we'd have to solve the quadratic equation, right? We'd either have to factor it or set it, or use the quadratic formula or something, right? But it's already factored. So we know by the 0 product property, remember that the product of two factors equals 0 when either one of the factors equals 0. Because the only way you can get a product equals 0 is when you multiply by 0, right? So good. So -3 is one of the places. If I plug in -3, I'm going to get 0 times some number divided by some number times some number. I don't care what the numbers are, right? 0 divided, I end up with 0 divided by a number, which is 0, right? So there's a place I know it. -3, I know the function has to go through that point. Those are, like in calculus, we'll talk about those as anchor points. So those are places where, we can anchor the function concretely to the graph in that place, right? Even if we're just doing a sketch, it's good to know some places where some points that the graph actually touches. And there's one of them. Okay, where's another one?
1.
Okay, 1. How come, Jill, how come 1 is also a place where the function is equal to 0?
The 0 of x.
Okay, that's the 0 of x minus 1. All these other factors are just going to give me numbers back, right? So I'm going to end up with 0 on the top and a number on the bottom, so I get 0. So there are two places, those are the zeros of the function, right? Okay, good, so that's good. Now we need to know places where the function is undefined, right? So we know that functions are undefined when we divide by 0. Okay, so Mr. Deminu, tell me, can you tell me a value of x that's going to make the bottom equal to 0? So if I set the denominator equal to 0, what's the value of x that's going to make that 0? -5 would, sure. Right, that's going to be the 0 of that factor. Okay, so then we know at -5, I've got something going on there, right? That's a place where I've got a 0 of the denominator. Let's see what happens in the function if I take a limit, if I explore the behavior of the function as x approaches -5. It can't equal -5, but let's get close to -5 from the left, right? From the negative direction. So we'll approach -5 from the left or from the negative side, okay? What's that going to do to each of these factors, right? So we can know what the overall behavior is going to be. Elizabeth, what's going to happen to this factor right here, x plus 3, as x approaches -5?
It's gonna be
-2, good. How about that one?
wait, and then approaching negative.
As it approaches -5, yeah. -6, I'll just keep picking on you. What about that one right there? Now this one's a little tricky, right? Because as we approach -5, it's gonna approach 0, right? But we gotta know we can't actually get there, right? That's the thing. When we're taking a limit, remember, this is the behavior like as I'm walking towards the door again. If every second I'm cutting my distance to the door in half for the rest of eternity, I never get to the door. But it's the one thing that I'm always approaching, right? There's not a place on the floor that I'll not get to eventually, right? You could never make a dot with an infinitely fine Sharpie. There's no point that I couldn't put on the floor that I wouldn't eventually walk on, as long as the point's not on the door itself. But I'll never get to the door. It's weird, but that's kind of the way math works. So what's that going to give me then? If I'm approaching -5 from the left, from values that are a little bit more negative than -5, it's going to be slightly negative or slightly positive. And I think it helps to think about this in terms of a decimal. So that'd be like, what's -5? What's slightly more negative than -5? So yeah, -5.01 or something like that, right? So -5 point something plus +5 gives me a leftover that is negative. Good. So I'm going to get a 0 minus, and then finally, as x approaches -5, well, that factor becomes -5, right? So what's the overall behavior going to be then? So I know I'm going to get, on the top I'm going to get, let's do it this way this time. Let's go ahead and just simplify. Let's multiply straight across on the top, just to show that this works. -2 times -6 is 12. So the numerator approaches +12. The denominator approaches 0 minus. So think a really small negative number times +5. What's that going to be? If I multiply -0.000001 times -5, what am I going to get back?
11,000.
I'm going to get back a very small number, but the sign's going to be positive. So that would just become, we might call that 0 plus. And so then I end up with 12 divided by 0 is infinite, and I get a positive divided by a positive, and so it's positive. Right? Yes, sir.
Wait, so if x was approaching -5,
Right.
and you're adding 5 to it, right?
Right. Mm-hmm.
Why is it negative?
Because, okay, what if we made a table out of this, right? That's another way we could look at this. We kind of visualize what's going on with this. And I get, this is kind of sort of an
You're
advanced,
approaching it from the left.
from the left, right?
Okay, so
Does that make sense?
I know you're doing it from the right.
So if we made a table, like, and I don't make the whole table, but if we made a table, something where we had x and y values, right? And so we're approaching, we can't ever get to the value -5 because there the function is undefined. But we could start like at -5.5, and we're going to get some answer, and then we'll try -5.4, and we'll get some answer. We just get closer and closer and closer, right?
I understand, I was just looking at it backwards.
Okay. Okay, makes sense? So if I want to draw this then, we've got an asymptote. Okay, so we've got an asymptote here at -5. And as we approach from the left, it's positive. So we know that it's going to be sweeping up to infinity, right? Okay, what about, let's fill in the blanks here. If we want to approach this asymptote from the left to see how the function sticks to it, what's going to go there? X is approaching what value? What's that going to be? What am I going to write there? -5 plus. Yeah, good. I'm approaching -5 from the plus, right? And what's that going to give me then? I'm going to get the same values. This stuff, these boxes or these values, they're aren't going to change, are they? Because I'm still approaching the same x value, right? Does it make sense that I don't really have to do, because this is a question I can see people asking. Why don't I have to make this like a -2 plus or minus? Doesn't matter, right? It's approaching -2, right? This is different because it's approaching 0 on the bottom, and so we can't just plug a 0 in there. We have to know, what is it? Is it slightly positive or slightly negative? It makes no difference if this is -2.001 or -1.99999. When I multiply it, it just behaves like a -2. They're almost the same thing. Neither one of those is going to impact the overall behavior of the function, right? So as x approaches -5 from the right, I'm still getting -2 from that. Hold it. Yeah, that's right. -2 for this one, and -6 for that one, and I'm going to get -5 for that one. But what about the x plus 5? Luke, what's that going to be if I'm approaching -5 from the right? 0 plus, good. So it's going to be like -4.99999 plus 5. It's going to give me a little leftover positive. Okay, so that's a 0 plus, right? And so then I end up with the overall sign. I know it's going to be infinite, right? Because I got a 0 on the bottom. What's going to be the overall sign? Just count the negative signs that are being multiplied and divided. There's an odd number, so it's negative, right? So we get negative infinity, and it's going to do, as we go towards -5 from the right, it's going to sweep down. Okay, get the idea? Question? It does, you're right, good point. It has to cross this point. So in this case, we actually have something, we know that it has to go through that point, so it's going to do something like that. Okay? You get the idea? Okay, what about at 1? As x approaches +1 from the left, what's that going to be? Emily? I'm going to get, let's just give these things, well, go ahead. What am I going to get here?
When you do positive one?
Yeah, +1 plus 3 is what? 4, okay. What's,
That's
oh, I'm supposed to be 0, sorry, my mistake. Yeah, what am I doing? Yeah. Whoops. All right. So yeah, so we're approaching, we want the 0 of this guy, right? We said that's going to be at, we said never marked it up here, but that's going to be right there, right? There's the other place where we're going to have a vertical asymptote. So as we approach 0 from the left, then that's just going to make all the x's go to 0. That's easy, right? So this becomes 3. This becomes -1. That becomes 5. Well, and what's x? If we're approaching 0 from the left, it's 0 minus, yeah.
What are those numbers you?
Say it again.
What are those numbers do?
What do those numbers do? Well, we could simplify this and we'd get 12 on the top and we'd get 0 minus on the bottom, right? And so that tells us, really all they're doing is, all we need is the sign of the numbers. I wouldn't even have to write the numbers down. All I need are the signs. I know I'm going to get 0 on the bottom and some constant non-zero number on the top. And so that's going to give me an infinitely big fraction, right? I just need to know, is it going to be positive or negative infinities? There's a big difference between the two. So this time I've got only one negative, but that's an odd number, so it's negative. Would you agree? Okay, so it's going to do something like,
Where'd you get the 4?
where did I get the 4? Should be a -1, shouldn't it? Yeah. Whoops.
You wrote
Oh, I wrote, that's what I did. So here I'm going to get a -1. So that's going to change it to a positive then, isn't it? Right?
You should have fixed it.
Makes a big difference, right? Because that's going away, that's going away, that's going away. So now I get 2 negatives, which makes it a positive overall outcome. And so it's going to do this, right? Because I've got another asymptote right there. Okay? So I got one more left to do, and that's, we got to know what happens as the ant walks backwards towards 0 from the right. What's he going to do? So as x approaches 0 plus, I'm going to get 3 times -1 times 5 times 0 plus. So now this time I do have just only one negative factor, odd number. And so the function's gonna go, did I do that right? Better check me.
Good, good.
Okay, all right. So on this side, it's gonna go down, right? So it's gonna do something like that.
Mr. West?
Yeah.
Is 0 an even number?
It is.
Is it an odd number?
No, no, it fits the pattern of even.
Why?
Okay? All right, we'll, there's a couple more things we gotta add to that, but we'll do that tomorrow.